It's a pleasure to be here in Washington, D.C. for ADHO 2024, even though it's still a bit early for me. Just we're going to be okay. I'm Hugo Scheithauer, a PhD candidate at University of Paris, and I'll be presenting alongside my colleague, Sarah Bénière, a research and development engineer in the same team. We'll talk about an automatic retro-structuration workflow for auction sales catalogs, layout, and content. This presentation has been created within the context of a research and development project, data catalog, for which Sarah and I are working. The objective of the data catalog project is to automate the transformation of digitized sales catalogs into a structured database, mostly using machine learning. As we'll see later on, we want to structure the information contained in sales catalogs to get to the atomic levels of information. By database, I mean transforming them into XML/TI, and one of our goals is ultimately to publish the structured data into the prediction interface. Our presentation is also called retro-structuration, mentioned retro-structuration, because we mean that we work with documents that were already digitized. All the documents provided by our partners institution, the French National Library and the French National Institute for Art History, gave us data that were already authorized and distributed to the public. We work on unstructured data created in the past, which we have now to structure. So basically, we inherit the quality of the data when it was created. Sales catalogs are valuable historical documents. They constitute vast knowledge bases on multiple domains, such as the history of economics, collections, but also art history, iconography, and cultural heritage in general. However, their exploration and content extraction is still a difficult task today, as they are redistributed only as pairs of images and unstructured plain text. The content available online today is nothing more than a continuous text without hierarchy. Their exploration is only possible with word matching research engines or with the metadata of the documents. But it is not possible to access a more fine-grained level of information, for example, sales types, dates, types of objects, etc. At the beginning of the project, we sampled digitized catalogs from our two partner institutions to constitute a data set which we could start experimenting, for example, adaptive, etc. On a total of over 150K catalogs available, we sampled 713 catalogs and selected 2 random pages from each. We aimed at a good representation of sales types such as numismatics, ancient books, antiques, fine arts, etc., but also document layouts and time periods. Our sample is mostly in French, although we have a bit of German and English. In the first phase of the project, between 2021 and 2022, we approached this task, the restructuration of sales catalogs, into TI with an open source machine learning tool called Robid. It is designed for extracting, parsing, and restructuring PDFs into XML/TI using machine learning. It works at the document level, and its models were trained mostly for structuring scientific publications, which the software really excels at. Its models can be retrained when you give it annotated data, even though it requires a lot of software engineering. And Robid uses a combination of textual and visual features to restructure a document. However, as I said earlier, we inherited the quality of the data given by our partner institutions. Digitized catalogs were authorized a while back, and the text sometimes, unfortunately, contains noise resulting from the OCR. Robid, we observed that Robid was sensitive to noise. And when looking more closely to the data, we can see that, for example, we were dealing with hallucinated characters that were mostly found on blank pages. Basically, the model thought that he detected the line of text, but not at all. And deconstructive tokens. Now moving on to our actual pipeline. We decided to switch to two-stage structuration. First, we have the macro structuration stage, where we leverage the object detection methods to deals with only visual features. It allows us to structure the general layout of the documents and to retranscribe document parts if necessary to eliminate all noise. Then we switch to the micro segmentation stage, where we theoretically deal with clean data, and that we want to approach as a token classification task. For the microstructuration stage, or layout segmentation stage, we use the YOLO model, which allows us to bypass the OCR noise in the first phase, since it uses only visual features. Our approach was motivated by the recent work of our colleague Thibaut Cléris and the growing popularity of Hugo engaged projects. Hugo basically segments an image into zones and attribute them a label based on the dataset it was fine-tuned on. We annotated all the 1,426 pages we have in our dataset to fine-tune a YOLO model for our project. The data catalog training set was annotated following the TI-based Segmento control vocabulary. Segmento offers a syntax designed for describing the content of books and manuscripts. Segmento is also used by a wider dataset called RADAS for layout analysis dataset with Segmento, and our dataset was conceived as a subset of this bigger dataset. Using the control vocabulary such as Segmento ensures that our dataset follows the FAIR principle. And if you want to know more about the design process of the layout analysis dataset with Segmento, our colleagues Thibaut Cléris and Juliette Janès will give a presentation on it tomorrow morning. Our fine-tuned neural model works well, even though the scores are not perfect, as you can see on the slide. But our qualitative study indicated that we could move forward to the microstructuration step. Here a quick example of a qualitative observation made. As you can see, the model accurately segments an image where images and text are mixed, which is very important when dealing with text catalogs. With our model and with layout analysis in general, the structure of the document can be segmented into meaningful text regions that allow to save the semantic of the layout. We can also extract handwritten notes and transcribe them in an HDR model, for example, and we can use semi-automatic quality evaluation tools of the text contained in text regions to assess if running an OCR model it is necessary. For the microstructuration step, we basically want to combine the text zone coordinates of text regions extracted by the YOLO model and the transcribed text to first generate a basic structure of basic TI structure, to then do the classification.
So we chose to structure the content of the catalogs using the TI standard. So the work we did was built upon that of our colleagues from the Atlas project who initiated this. So TIS, I believe most of you know, makes documents interoperable. It's very interesting. We can have structured, enriched, standardized, and reusable data. So to do so, we created an ODD or ODT, called Data Catalog, which is a customization of the TI thought especially for encoding sales catalogs. So we use the TI elements that are already available, of course, but our colleagues from the Atlas project suggested that we created three new elements: catalog entry in red, catalog desk in blue, which is, for example, gives more details about dates or persons concerned by the entry, and then the catalog item specifically in green. This is where our micro-segmentation step comes in. So as Hugo said, as a token classification task, and especially named entity recognition. So here's a view of which information we want to extract from the items: the entry number, object description, bibliographic information, object dimensions, and conservation comments, for example, which gives us this. In TI for now, it's still an ongoing project. We're still working on the data structuration, but you can see the catalog entry at the top. This is an entry where there was no catalog desk, so it's in a comment. And then the catalog item and the TI elements already present in the guidelines that we are going to modify and customize for them to fit into the data catalog entities. That's where we're at now. We still have to do the micro-segmentation task and finish up the review, which will be available on GitHub, as well as the definition for the three new elements. And then our goal is to finally publish the enriched catalog on a TI publication. TI publisher application. Thank you for your attention.
Thank you.